Welcome to this chapter titled Fundamental Principles of Mechanics. Mechanics is an essential branch of physics that focuses on the study of motion and the forces that cause it. It forms the foundation of many applications in everyday life and engineering. This chapter will guide you through key concepts of statics, which examines forces in equilibrium, dynamics, which studies forces acting on moving objects, and Newton's laws, which are fundamental to understanding how bodies behave under the influence of forces. We will explore these principles to provide a solid foundation for studying mechanics and its practical applications. Let's begin. Mechanics is the study of motion and forces. It is divided into several essential branches, including statics, dynamics, and the study of the laws of motion, which help us understand and predict how objects behave in various situations. Statics Statics focuses on the study of the equilibrium of stationary bodies. It examines the forces acting on an object without causing motion, allowing us to analyze how these forces balance to keep the object immobile. Dynamics Dynamics, on the other hand, studies the motion of objects and the forces that cause it. It helps explain how and why an object moves under the influence of different forces such as gravity, friction, or an applied force. Laws of motion. The laws of motion, formulated by Isaac Newton, are universal principles governing physical interactions between objects. These fundamental laws explain how bodies respond to forces and allow us to accurately model the behavior of moving objects. A force is an action that can cause a change in the motion of a body. It is defined by several key characteristics. Point of application: the point where the force acts on the body. This determines exactly where the force is applied and influences how the body reacts. Direction: the line along which the force acts. It defines the orientation of the force, horizontal, vertical, or any other direction. Sense: orientation indicates in which direction the force acts along its line of application, for example, to the right or upward. Magnitude, intensity, the strength of the force measured in newtons, N. It determines the force's size and can be measured using a dynamometer. Statics is the branch of mechanics that studies the equilibrium of stationary bodies, that is, the conditions under which an object remains at rest under the action of forces. It is based on two fundamental concepts: equilibrium of forces and equilibrium of moments. Equilibrium of forces. For a body to be in equilibrium, the vector sum of all the forces acting on it must be zero. In other words, the total of all applied forces must cancel out so that the object does not move, meaning there is no linear acceleration. Equilibrium of moments. A moment of force is the effect of a force relative to a point of rotation. For equilibrium, the product of a force and its perpendicular distance from the axis of rotation, the lever arm, must be zero. This means the turning effect's moments balance out and no rotation occurs. Center of gravity, the point where the total weight of an object is concentrated. It determines how gravity acts on the object as a whole and plays a key role in analyzing balance and stability. Applications of statics can be found in several key fields: civil engineering, used in the design of bridges, buildings, and dams, ensuring structural stability by analyzing forces. Mechanical engineering helps analyze the forces within machine components to ensure proper operation and strength. Biomechanics, applied in ergonomic studies to analyze forces acting on joints, helping prevent injuries and improve comfort. Dynamics studies the motion of bodies under the influence of forces and explores the principles governing these movements. Key concepts in dynamics include Newton's laws, the fundamental principles governing the motion of objects. These laws explain how bodies react to forces and allow predictions of their motion. Energy and work. Dynamics examines the work done by a force and the kinetic energy of a moving object. It links the applied force to displacement and energy transformation. Momentum, the measure of an object's mass in motion related to the principle of conservation. It remains constant as long as no external force acts on the system, which is essential for understanding collisions and body interactions. Applications of dynamics are widespread across different fields for analyzing and optimizing motion under force influence: automotive, used to study the forces acting on a vehicle during acceleration, braking, or cornering, improving safety, performance, and energy efficiency. Aerospace, applied to the study of satellite and rocket trajectories, considering gravitational and propulsion forces to optimize space missions. Industrial, plays a key role in optimizing power transmission systems in industrial machinery, maximizing efficiency and minimizing energy loss. Newton's laws describe motion and the forces that cause it. They are the fundamental principles of dynamics. First law, law of inertia. An object at rest remains at rest, and an object in motion continues moving in a straight line at constant speed unless acted upon by an external force. Second law, fundamental law of dynamics. The force applied to an object equals its mass multiplied by its acceleration, F force mxa. This explains how an object's velocity changes when a force is applied. Third law, action-reaction principle. For every action, there is an equal and opposite reaction. If one object exerts a force on another, the second object exerts a force of equal magnitude but opposite direction. Mechanics, as a fundamental science, plays a crucial role in understanding the motions and forces that shape our environment. By mastering the principles of statics, dynamics, and the laws of motion, we can design safe and stable structures, optimize power transmission systems in machines, and solve complex challenges across various fields. Whether it's building design, vehicle performance improvement, or space trajectory analysis, mechanics helps us better understand and control the world around us, providing efficient, safe, and innovative solutions. Thank you for your attention.